So this is a brief review of domain and range. So the domain and range of a relationship or a function just describe all the possible x values and all the possible y values. Domain we know is for x, range we know is for y. So considering this situation down here, we've got a circle on the graph, or a crudely drawn, might I add, circle on the graph. And a circle we know isn't a function. It's not a function because for any given input, like this point 1, you've got two different outputs. So it fails the vertical line test. But it still has a domain and range. So the domain being all possible x values, you have to look at it and think, okay, how far does this thing go on the x-axis and will it continue? Well, it seems to go from this point here all the way over to this point here. So this means that x must be less than or equal to 2, but greater than or equal to -2. And even though like I said, it's a crudely drawn circle, so you may be saying, well, that blue line doesn't quite hit the -2, and this line doesn't quite hit the 2. That's just because I'm not a very good, artist on this application. But I meant for it to be there on the 2. And you'd be right. If it wasn't quite on the 2, you'd have to try to identify what number it was on and say that x is going to be greater than or equal to this value, but less than or equal to this value. So we're constrained in this limit. And similarly on the y, you're probably seeing the same thing. On the y-axis for the range, we are constrained between 2 and -2. And so the radius of this circle must be 2, and it's centered at the origin, right? That would make sense based on the domain and range. So that's pretty much all there is to it. But on the next example, there's one little caveat and something I think is really important to consider. So stay with me for the second example here. So if you're just given a simple situation like maybe you're told every single score made results in 2 points. So at 0 scores, there's 0 points, and so on and so forth. Every score, you make 4 scores, there's 8 points. So if I was to just graph these points over here, I don't have them all graphed on this graph, but you notice that they're not connected with lines because we're not going to be able to score in this particular game half a score, or 1 point, or even a half a point, or even a quarter of a point, or really any of the numbers between these values. We can't score half a score, and the actual points go up in terms of 2. This is something we call discrete. It's discrete because they're really not connected, and we're only considering the data given, right? Well, that leaves us with one question. How can we describe the domain and range of a situation like this? Well, there's one thing you could do. You could say that the domain are all the possible inputs or x's. So these are obviously all my inputs. The domain, we could say, possibly, are all whole numbers, right? So they're whole numbers, including the zeros, so whole numbers. And we could describe the range. Let me move this up a little bit. We could describe the range possibly by simply saying, even numbers, right? They appear to be even numbers. But that's one way to do it, but that assumes that this thing keeps on going. I mean, we were given basically no information, right? So that's what you might want to write if you assume that this kept on going forever. Well, if I get these out of the way, let me shrink these down here, get them out of the way. What would we do if this was all there was? So if we were told this is the results of the game, there's nothing more that's going to happen, what's the domain and range of the game? Well, that's actually the easiest thing to consider. Because the domain, we would say, if this was all the data and it wasn't continuing, and we might use these fancy little parentheses, the domain we would say would be 0, 1, 2, 3, and 4. We would actually list out all of the x values, because remember what domain asks for, or the question that it asks. It's what are all the possible x values? Well, if this is the only data that we're ever going to get, if the game's over and it's not going to continue, then 0, 1, 2, 3, and 4 are the only possible x values. Similarly with range, we would just simply list them. So we might want to use these fancy parentheses again, and we would say 0, 2, 4, 6, 8, because that's the only possible range values. It really depends on the context of the problem and the type of situation. And anyways, I include for you a few more examples with parabolas. So if you think you might want additional examples for finding the domain and range of some parabolas. Stay tuned. So this crudely drawn parabola, well, it's actually, it's not an x squared, it's a y squared situation. It's going to the right. So the question is, what's the domain and the range? Well, the domain, which is all the possible x values, they look like they're going to start here, start at this point, right? And then they're going to go right forever. So x could be really anything right of that point right there. And that point right there on the x-axis is -2. So I'm going to say that x has to be greater than or equal to -2. And the reason I say greater than or equal to -2 is the parabola actually goes through that -2. Now, the actual range, now you have to ask yourself, will this thing ever stop going up or down? So is it ever going to stop increasing? Is it always going to keep going this way? Is it always going to gradually make its way down? And the answer to that is yes, if you understand these sort of functions. And because I know that, then I'll say that the range is all real numbers. And I might just use let me try and make that a little bit clearer. It's just like a special R with a double back to it. Kind of stands for the set of all real numbers. So that's what the range is. We've got one more for you. So in this particular situation, we've got your normal sort of parabola. It's heading up, and so the domain in this particular case are all the x values. So will this thing ever stop going to the left, and will it ever stop going to the right? Even if it's gradual, even if it goes way up, but it's still going to end up going right. And the answer to that is yes. It continues to go left. It continues to go right. And so the domain then is simply all real numbers. But the range is a different story now, because this thing's never going to come down in this direction. This is like its spot right here. So the range, y has to always remain greater than or equal to 3, because we're at 3 on the y-axis there. And it can't go below that. So that's really all there is to domain and range. Thanks for watching, and I hope this was helpful to you guys who are reviewing for your finals.